In this video, we'll cover the concepts of decimals, not the operations with them, but just an introduction to decimals, which will prepare you for the first set of activities. So if you look at the numbers that we've worked on so far, let's say we had the number 364, and assuming we're working in base 10, then we had place values for each of these numbers. The 4 was either the units place, sometimes we called it the ones, because these were individual units, 1, 2, 3, 4, 5, until we got all the way up to 9, and then we regrouped them. So the second place were the tens place, and so everything here was 10, 20, 30, 40, 50. When we got up to 90, if we added another 10, then we came up with hundreds. And after hundreds were thousands and 10,000s and 100,000s, etc., as we went further and further left. So in other words, in powers of 10, this was 10 to the 0 power, which was worth 1. This was 10 to the first power, so everything in that column was worth 10. Everything here was 10 to the second, which is 100, and then we had thousands, etc. But you notice we were always dealing with whole units. 364 had no parts to it. It was just 364 whole units. The question now is, well, what happens if I don't have only whole units? What if I have 364 and a half? Well, then I have to indicate that somehow, and the way I do is with a decimal point. So this decimal point was always there, right? We didn't write it if we wrote 364. We generally didn't write 364 and then a decimal point. We just wrote 364. But what if there was a number on the other side of the decimal point? So what if it was 364.5? Well, what do we call that? What we do is we call this first place a tenth. Okay, so 364 and 5/10. Well, what if I have 364.52? What is that? Well, that is a hundredth. Not a hundred, a hundredth. What if it's 364.523? Then that next decimal place is called the thousandths. Okay, so now we've got tenths, hundredths, and thousands. So what's in the first column are things that are worth 1/10. What's in the next column are things that are worth 1/100th. And the next column are things that are worth 1/1000th. If you remember negative exponents mean that the value wants to switch places. So for example, if you had 10 to the negative first, 10 to the negative first is 1 over 10 to the first, which is 1/10. 10 to the negative second is 1 over 10 to the second, which is 1/100th. When those exponents move, in other words, from top of the fraction to bottom of the fraction, they change sign. So they're no longer negative when you move them down the bottom, now they're positive. So 10 to the negative second is the same as 1 over 100. 10 to the negative third is the same as 1 over 10 to the positive third, which is 1 over 1,000. The reason that I'm bringing this up is not so much because I'm doing a lesson on negative exponents, but more so to explain that the decimal naming system is consistent. In other words, the stuff that I have here in purple, 10 to the second, 10 to the first, 10 to the 0, what happens when it crosses that decimal point is the exponents just continue to decrease. 2, 1, 0, -1, -2, -3. Now, when you introduce decimals, you're not going to introduce them in terms of negative exponents, but the process of coming up with them is exactly what I just explained, the negative exponents. All right, what really you're going to focus on is you're going to focus on the names of those places. So on the one side, units, tens, hundreds, thousands, those are all wholes. The pieces that are less than 1 are the tenths, hundredths, thousandths, 10,000ths, etc. And so this is just a little information slide, the same thing that I mentioned before. When you read these, right, 37.953, how do you read it? You read it as 37 and 953 thousandths. We can also expand it and write it as 37 plus 9/10, right? So here's my 9/10. And then the 5 represents 5 hundredths, 5 over 100. And then the 3,000ths can be written this way. And so when we read it, we don't read it as 37 and 9/10 and 500ths and 3,000ths. we read it as 37 and 953 thousandths. All right, this is a nice little chart that explains how to read these things and how to write them in their values. The number here is 12.61843. So how do we properly read that number? We don't just read it as 12.61843. We read it as 12 and, that decimal point tells you to read and, 61,843 hundred thousandths. That's what comes to the right. So tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, and then it would just continue, right? After 100 thousandths comes millionths, 10 millionths, 100 millionths. You're probably not going to have to go that far. 100 millionths are very tiny pieces. So the word decimal comes from the Latin word decim that means 10, right? Everything is in base 10. And so we can rewrite that number that I was just talking about as what? One group of 10, 2 units, 6 tenths, 1 hundredth, 8 thousandths, 4 ten thousandths, 3 hundred thousandths. Okay, so just like we were doing before when we had like 364, we said they were 3 hundreds, 6 tens, and 4 units. The same thing here. We can break them down into tenths and hundredths and thousandths and 10 thousandths. And again, how do we read that number? 12 and 61,843 hundred thousand. So we always go by what the smallest value is on that number when we go to read it, and then we just take the whole rest of the set of digits with us. All right, here's another example. Took this from a different book. 325.168 represents what? 3 hundreds, 2 tens, 5 ones. Those are your whole number units. On the other side of that smiley decimal point is 1 tenth, 6 hundredths, and 8 thousandths. So 168 thousandths, 325 and 168 thousandths. So some books will have you write them in expanded form. This down the bottom here is expanded form. 3 groups of 100, 2 groups of 10, 5 units, 1 tenth, 6 hundredths, and 8 thousandths. So then the next question that comes up might be, well, where do these things fit? Suppose I asked you to find me the location of 0.16. What is that number? First place is tenths, second place is hundredths, so it's 16 hundredths. Where is 16 hundredths on a number line? Well, I mean, we might start by making ourselves a number line and marking off the places we know, like 0 and 1. Well, somewhere between 0 and 1 must be a half, and then we can break this into 4 equal parts and this one into 5 equal parts by making 4 dashes. And now each one of those little dashes is worth a tenth. So that's 0.1, that's 0.2, so 1 tenth, 2 tenths. I'm just putting them on opposite sides because otherwise they're all going to run together. So where exactly is 16 hundredths on this number line? Well, 1 tenth is smaller than that, and 2 tenths is bigger, so it's got to be somewhere between 1 tenth and 2 tenths. What I'll do to help make this a little bit more clear is I'll draw myself a second number line. Okay, so I'm going to make a note that I'm going to pick this part in here, and I'm going to expand that into a second number line. Where now, instead of going from 0 to 1, my number line is going to go with markings at 1 tenth and 2 tenths. So remember, the number line goes on forever. So really, I'm just picking a little piece of that number line and I'm expanding it. Sort of like if you're looking for something on Google Maps on your phone and you want to zoom in on a particular town or a particular neighborhood or a particular street to find a certain, I don't know, coffee shop or whatever, friend's house, whatever you're looking for. You know, a map of New Jersey may not be the best place to find your individual friend's house, but if you keep zooming in, eventually you'll get to the right street and you can look for the right numbers and everything. So I'm doing the same thing here, right? I'm starting with an infinite number line. I'm narrowing it down to, well, it's got to be between 0 and 1. Now I'm narrowing it down between 1 tenth and 2 tenths. What's halfway between 1 tenth and 2 tenths? It must be 15 hundredths. Right? If you think of it, 1 tenth is 0.10, 2 tenths 0.20. So what's halfway in between? 15 hundredths, 10 hundredths, 15 hundredths, 20 hundredths. Okay, so now break this down. This would be your 0.16, 0.17, so 16 hundredths, 17 hundredths, 18 hundredths, 19 hundredths, 20 hundredths. There's my answer. There is 16 hundredths on the number line. So I've drawn myself two number lines. I've narrowed it down between 1/10 and 2/10, and then I've broken those pieces up so that I can get a more precise answer of where 16 hundredths is. And you notice things that were equal are marked off as equally as I can here. In other words, between 0 and 1, there should be 10 equal tenths, and so I try to make them as equal as I can as I break those apart. All right, here's an example that's worked out for us that's a little bit neater than the one I did. Suppose I want to find 38 hundredths on a number line. So we start first with a number line and we mark off integers between 0 and 10. Right? Like I said, the number line goes on forever, so it includes negatives too, which is not really part of what we're doing, but it does include negatives to the left of 0. But if I want 38 hundredths, I'm going to need something a little more precise. So now look at what I did. I took the number line that I had up here and I broke it down into just the digits between 0 and 1, because I know that 38 hundredths is more than 0, but less than 1. So it's got to be somewhere in between there. Okay, so I've marked it off, and I marked them off in increments of 10th, 1/10, 2/10, 3/10, all the way till I got to 1, which is 10/10. Now, where on this number line is 38 hundredths? Well, it's somewhere in between 3/10 and 4/10, right? Because there's 3/10, there's 4/10. 38 hundredths is somewhere between 30/10 and 40/10. So I draw out that number line down the bottom that starts at 3/10 and ends at 4/10. Now when I mark off equal markings, I'm not marking off tenths anymore, I'm marking off hundredths. 31 hundredths, 32 hundredths, 33 hundredths, all the way till I get to 40 hundredths. And you can see now I've made a mark right there where 38 hundredths is. And that's how we identify where these things are on a number line. You notice as I did these, it looks like I added extra digits, because I started with 0.3 and 0.4, and somehow when I wrote them up here, I wrote 0.30 and 0.40. Well, I didn't really add extra digits. What I'm doing is marking them off so that they look the same, so we're measuring with the same unit. So I have 30 hundredths, I have 40 hundredths. In between there are 38 hundredths, which is the number I was trying to find. What if I asked you a question like this? I gave you 0.27 and 0.3. So what do those things mean? 0.27 is 27 hundredths. 0.3 is 3/10. Where do the two of them belong on the number line? Well, we could start with numbers between 0 and 1. Right? Both of these numbers are greater than 0 and less than 1. When we break it down, we might want a 0.2, a 0.3. Which of these two numbers is bigger? The 0.3 is bigger. Right? 27 hundredths is smaller than 30 hundredths. So if this is 25 hundredths, then that's 27 hundredths. So 27 hundredths is smaller than 3/10. And we can see with the same set of pictures as before, right? We went from 0 to 1, broke that down into tenths, and then broke the segment between 2/10 and 3/10 into hundredths, and we can see 27 hundredths is less than 3/10. So sometimes students end up with some misconceptions about the values of these decimals. There's our number line again. Sometimes students will say that 0.3 is smaller than 0.27. Why? Because 3 is smaller than 27, or 27 is greater than 3. In other words, rather than treating them as decimals, they're treating them as whole numbers. They're ignoring that decimal point, and they're saying, well, 3 is bigger than 27. And that's true. 3 is bigger than 27. But that's not what the question asked. The question asked 27 hundredths versus 3/10. Another misconception is looking at them as tenths versus hundredths and saying, well, 3/10 is smaller because 0.3 is in tenths, 0.27 is hundredths. In other words, mixing up the place values, thinking that hundredths is bigger than tenths when it's not. Hundreds, with a D at the end, is bigger. Hundredths is smaller. So when you go to the other side of that decimal point, the values keep going down as you go from left to right. meaning that the tenths are bigger than the hundredths. So 3/10 is more than 27 hundredths. And placing those values on a number line can help students to see that a little bit more clearly. So this is something that if I were doing this in person, I would have actually started the class with, but at this point in the lecture, it's probably easier to introduce this now, because now you can play this game a little bit. And once students get to this point, they can start to play this game to illustrate a point, which is start by picking any two decimal numbers. So here I'll do one round, and then we'll wrap this video up and do another one for the second part, and you can play this game a little bit. So it says start by picking any two decimal numbers. Right, so what if I pick 12.64 and 12.93? Right, so 12 and 64 hundredths, 12 and 93 hundredths. Call the smallest one the target. It says put the greater one at the top of a list. This one is the target. Students take turns placing new decimal numbers on the list. Each new number in the list must be less than the previous number, but greater than the target. So I'll say 12 and 72 hundredths. That's my next number. Okay, it's less than 12.93, but it's bigger than the target. All right, then you got to come along and you've got to find another number that's less than 12.72, but greater than the target. So here, what if I say 12.65, right? 12 and 65 hundredths. That's less than 12 and 72 hundredths, but bigger than the target. Well, now you've got to play next. What are you going to do to find a number that's bigger than 12.64 and smaller than 12.65? Well, what if you said 12.645? I'll bet you that one fits nicely in between 12 and 64 hundredths and 12 and 65 hundredths. So if you want to write out the decimals, 12 and 65 hundredths looks like this. 12 and 64 hundredths looks like this. What did I do? I just put 12 and 645 thousandths right there in the middle. Okay. This game will go on and on forever because every time you go to find a number in between, and it doesn't have to be halfway in between, right? I could have put 12 point, if I want a number now in between those, I could put 12.641. It doesn't have to be halfway in between. It just has to be numerically in between those two values. And so this game can go on forever because if you get stuck, like I had 12 and 64 hundredths, 12 and 65 hundredths, what goes in between them? Just keep adding decimal places, right? If somebody says, my numbers are 12.997 and 12.998, well, you can insert here 12.9971, and that's bigger than the bottom number, smaller than the top number. So this decimal game can go on and on forever. Right. And then if you really want to play with points, you can score a point if you catch somebody else's mistake. All right, we'll wrap this up and we'll go on to a second video using manipulatives to illustrate decimals.